Welcome. In the following tutorial, I will demonstrate how to make tank threads with MSPhysics. We begin by drawing one of the tank threads, and it should be like a rectangle or something. And then we make it a component, and having the thread, we copy it along our preferred path. Yeah, maybe that's too much. And at the curvature, at the endpoints of the track, we curve the thread so that we could put together some wheels in there. Yeah. Now I'm not sure what the radius of the wheel will be, so I will first put that track. Well, I will first do the curvature of the track and then draw the wheels. Yeah, that's not how it's done. Yeah, I have to copy all this and then rotate 60, maybe more, maybe 15 more. There we go. Alright. $60, so it should be 75 then. Yeah, looks fine. Oops. Now after getting one of the curvatures done, we continue copying the track along the surface. I mean, along the upper whatever it is. And we don't want to copy it like this, because we want the orientation to be preserved. So if it's the vertical thread piece, the z-axis should be facing down, for example, and if it's the lower one, it should be facing the opposite direction, which is upwards. So we copy the upper thread, and let's put it like this. Yeah, and then we do the same thing for this side. Now we don't want to copy this side as well. We want to continue the orientation, so we will have to perform the rotations once again. Alright. Now we put together a wheel. Yeah, this one should be, the center should be like this. Yeah, there we go. Now all threads lay perfectly over the segments of the circle. Or I should say it's a polygon. Yeah, we would also want those to be components, and yeah, we copy them. Maybe we should make it a little thicker. Now here's where the interesting part starts. We create one hinge joint. Now this creates it everywhere in all of the thread pieces because they're components. And what we do next is use the joint connection tool to connect one of the thread pieces to its neighboring hinge. So I hold the control key and press on the hinge, And here it asks us whether we would like to connect all components to their neighboring joints, all alike components to their neighboring joints, and we press yes. And now we see that all components are connected, or all instances are connected to their neighboring joints. And this piece done, we can just test how well this thread works. Let's make it static, and let's see how this goes. Yep, this works quite nice. Now what we can do is we can adjust properties of any individual hinge joint, and because it's within a component, all other hinges will be edited as well. So we can actually adding angular friction is necessary part. It will prevent the joint from being too unstable at particular times. And so if you press play, yeah. And also we don't want to enable this connected collide option. This option it makes the neighboring connected thread pieces to collide, and if we enable it, it's not gonna work too well. It's going to it's gonna get out of control a little bit. So it's better to keep this option turned off. Now what we need to do is extend the floor and copy the entire thread sideways so that we have two threads. There we go. They are separate. And having that part done, we can create a small body for the vehicle. Let's make it like this. No, it doesn't look too good. Yeah, whatever. So let's see. Let's put it like this. And within the body, we need to create motor joints. And in order to do this, we will first locate the center point, and then use the motor joint. And directions where the motor joints are pointing, we are facing them in the same direction. So when I created the motor joints, they were all facing in the opposite direction to the y-axis. So this way it would be easier to add the controls to it. So here we would like to use keys like W, S, A, and D keys to control the this tank thingy. And in order to do this, we are going to create a small script. Here, let's put it like this. So we have two variables. Like one variable will control the left side, and another variable will control the right side. So set var L0. This is the starting value, and every time every time frame updates or frame advances, we update the variables to the values of the left, or to the values of A, S, D, and W keys. So let's write a WSAD controls. That's just a comment. And here we're going to say that left is equals to lefty. Lefty is W minus S key, or it also represents the joystick particular button or particular it represents the left joystick if you have like a Xbox controller or something. And over here we're gonna subtract the left X, which is left and right keys, and for the right side we're gonna have left T, the same thing, but also add the left X. So here we then update the shared variables LL RR. That's the script here. So now we have to access these variables within the motor joint. Get var, that's left side, get var L, get var L, this one is get var R, and that wheel is also get var R. Now if you want to add the properties of the motor, we will do this later. So let's first save this somewhere and see how this goes. Oops, yeah, forgot to connect. So this wheel connects to this motor, this wheel to that motor, this here, and this one here. Now we can check how this goes. We already see the joints are a little unstable, and to fix this we'll have to manually assign masses. So in order to do this, we will first name all tread pieces like tread, all wheel pieces as wheel, and now when we edit one tread, for example, we could use this button to edit all other treads. Let's see, by mass, let's make it 1, and we click assign options to all with name. There we go. And for the wheel, we're gonna make the mass to be, I don't know, 3, for example. Assign options to all with name. And for the body, we're gonna make the mass, should be small as well. I mean, MSPhysics is a little weird with the way it behaves when the masses are too different. So it's best to keep them as similar as possible, even though naturally we know that the mass of the body may be much higher than the mass of an individual tread piece. Here the mass is 10 and here the mass is 1, but in a real world scenario the mass will be like 1 and this will be like 1000 or something. However, like if we in the MSPhysics, if we make this 1000, it's not going to behave well. It's going to be unstable. So yeah, we can also turn off the joints or like hide joint layer whenever a simulation starts. This is for visibility, and we also would like to move those joints toward the center of the tread. This way it's going to be a little more stable. Here it is. Oops, something's wrong. There we go. Still unstable. Oh yeah, to prevent the thread from sliding off the wheels, well, let's first fix the instability issues. The reason it's unstable is because it's because material thickness, or the actual thickness of those thread pieces, is a little larger than they look. So this property is adjustable within the simulation tab. It's called material thickness, and we would want to turn this off. And also for the world scale, we would want to set this to 1. The solver model, it should be 16 passes, and the joint algorithm should be fast. If I set it to accurate, it's going to crash at some cases. So it's better to keep it at fast. Now let's see how this goes. There we go. Still a little unstable. Quite unstable actually. Let's see what we can do. So first, what we can try doing is set the stiffness to a little lower value, like 0.998, and yeah, keep the angular friction at 10. Let's see what happens. Yeah, that's a little better. But now we want to prevent the threads from sliding off. One way to do it is to add small discs at sides to prevent them from sliding off, but a better way would be to use a plane joint. We create a plane joint so it faces in the same direction the motors are facing. We can move it upwards so we can see it, and within the plane joint we enable rotation and we basically connect some of the thread pieces to the plane joint. Now it's going to make those thread pieces always aligned to the plane relative to the parent body, relative to the body of the tank. And we also want to connect some of the joints from this side as well, or some of the thread pieces. Oops, you don't want to touch the wheel. There we go, like this. Yeah, this looks fine. Now if we play simulation, you can see how this goes. One way to prevent so you see that it's a little it's sliding a little. So even though this one is rotating this way and this one that way, it still goes forward, or it went forward. We can fix this by reducing the mass of this thing. Yeah, it's a little strange. And yeah, let's see. Yeah, so now it responds a little faster. So if the more identical the mass of this thing to the mass of individual thread pieces, the more stable this thing becomes, or in terms of working properly. And we also noticed that with the plane joint, the thread pieces no longer slide off the wheels. Now what we would also like to do is adjust some motor properties, and here we could, just for convenience, we could assign a identical name to all the joints, like, I don't know, power or something, and yeah. So now all 4 motor joints have same name, and when we edit the properties of one joint, like let's say we want this to be 40 and this 10, we can assign to all with name and type. So this will assign to all motors of the same name with a name power. And should the controls be changed as well? We click no, because some motors have different controllers. There we go. Save the model just in case, and there it is. Let's see. Let's try assigning the let's try assigning a different collision. Maybe this will fix the issue. So if you assign the box collision to a thread piece, assign option still with name, and a convex hull to a wheel. This may fix the issue, but I don't know. We just gotta see how this goes. Oops. Yeah, this looks a little more stable. Now we can also try increasing the bending or the angular friction. Yeah, I think this one is a little too much. Maybe not, I don't know. Let's see. Yeah, this actually looks fine. Maybe not. Maybe it should be a little lower. Maybe like 50. And we could also try increasing the stiffness. Maybe with the higher angular friction is going to be a lot more stable. But if not, we will reduce it back down. Yeah, it looks fine. So this sums up the tutorial for this tank thread. Thanks for watching.